Now that we have created 2 new features out of a data set, we're going to try to evaluate those features in this lesson. Hi, this is Shanko and welcome back to NLP with Python. So in a previous chapter or in a previous lesson, we created these 2 columns inside our data set: text length, which stores the length of each text, or it stores the length of each text message, and the %% column, which gives us the percentage of punctuations that are present inside the text message, right? And in this lesson, we're going to try to plot these features on histograms, and we're going to try to evaluate these features. So for that, first I would import from matplotlib import pyplot and import numpy as np, and then I'm going to say matplotlib inline. So that's going to show the histograms, or that's going to show the diagrams inside the notebook. And I'm going to go ahead and run this, and let's try to create histograms for this column first, text length, and we'll categorize them into ham and spam. So for that, I would say pyplot.hist, and we are working with dataset, and we are working with this column of dataset. So I would say text underscore length, and we want the labels which are ham, or the text messages which are ham, right? So I would say dataset and label. So the label should be ham equals ham. So that's our that's the data that we are working with, that we're trying to plot. And next we need to give the bins. So I would say I'd create my own bin, and I would say bins equals, so I'm going to use the np or numpy, and I'm going to say linspace, and our x-axis should begin at 0 and we'll go till 200. So I'm expecting that there are no text messages whose length is more than 200, and we'll be saying 40. So that's going to create 40 different 40 equally spaced numbers between 200, and our bins are going to be placed there. So I'm going to pass in this bins for plotting the histogram, and then I'm going to say alpha equals 0.5. So that's the opacity for the histogram. So I'm going to say 0.5 for that. Next I'm going to say density equals 1. So that would normalize the hams and the spams, and if we do not do this, the hams are going to overshadow, or the hams are going to dwarf the spam, because we have more number of hams than spam. So I'm going to say density equals to 1, so that's going to normalize everything. And I'm going to say the label as ham, right? And we need to plot the spams as well. So I'll just copy this and paste it on the next line, and I change this to spam. Copy this and change the label to spam, and I'm going to say pyplot dot legend, and I'm going to give the location as upper right, and I'm gonna call pyplot.show. So that's gonna build the histogram and show it on our notebook, right? So I'm gonna go ahead and run this. All right, so this is how the histogram looks, and we have got a very nice diagram here, and this bimodal distribution is really good for our model, and we can see we have a lot of ham or rather we have a lot of spam messages which are greater than 125 characters in length, and the ham messages are kind of concentrated towards this side. So this is a very nice feature, or this is a very nice feature that we have actually discovered, and we should be adding this to our model to evaluate or to predict whether the message is spam or ham, and this can be a very useful feature, right? So let's try to evaluate our other feature, punct percentage, and we're going to do the same thing for punct percentage as well. So I'll just copy this and paste it here, and for the upper limit I'm going to say 50. So I'm just hoping that we don't have the punct percentage more than 50 inside our file, and I'm going to leave the number of bins as they are. And for this we are working with punct percent column, so I'm just going to copy this, I'm going to copy the whole thing, and I'll just paste it here. Sorry, punct percent, and paste it here as well. And the other things would remain same, and I would just go ahead and run this. Okay, so this graph is doesn't look very convincing, or doesn't look as good as this one. This is basically a bimodal distribution, kind of a bimodal distribution that we have, but this doesn't really provide much context as of now. And we can see we have a few spam messages that are really concentrated in this part, and we have a long right tail for the ham messages kind of here. So we can say that there are quite a few outliners inside a data set, or we have quite a few outliners, and this is kind of skewed. This data is kind of skewed, so we need to apply some transformation on this data to make it useful and to be able to use it with our model, and while trying to build our model which can predict whether a message is spam or ham, right? So that is all for this chapter, and in the next lesson we're going to try to transform some of the features that we might need to transform and make them more useful for building the model. And stay tuned for the next chapter. Bye.